Okay, I guess I'm live and back talking about inheritance, kind of part 2. Hopefully everything is running correctly here. All right, so this is going to be a little bit more lecture, a little bit less demonstration. So we're going to be talking about more concepts of object-oriented programming here. You've seen sort of, basic application in the last video. So hopefully a lot of these things will sort of make sense, and they're kind of just more refined and specific cases where you might want to use one or the other, or even sometimes when you're using those techniques, you're using them in service of some of the things we're going to talk about now. Okay, so polymorphism. What polymorphism is basically using the same name for different methods, right? It's having multiple forms for something. Right? Using the same name for differing methods or differing types, right? We have a common way of referring to something, even though it has multiple forms. There's two main types of polymorphism we're going to talk about. One, which is compile time, and the other one being runtime. So compile time polymorphism is usually done within a class, right? So that's being done, like, for instance, some of the things that I was doing, creating overriding functions that were all happening at compile time. But then I was using the weapon system, kind of plugging in things sort of on the fly. So it's kind of sort of a runtime polymorphism where I could change the behavior of my weapon system by using different classes or different classes that were derived from one another to change some functionality. But at compile time, I was also referring to within the single weapon class. I was looking at weapon class and weapon 2, weapon 3 to kind of figure out what was going on at that. Right. So I have a couple of different approaches that I could potentially take here. All right. So let's talk about them. Compile time polymorphism. So using the same name for different methods with different arguments is the classic case of compile time polymorphism. So for example, I might have two forms of this printIt function, one which takes a single argument, the other one which takes two arguments. Now, you may remember from working in Unity with the instantiate, for example. Instantiate allows you to say, okay, do you take the, do you specify a transform, which is a parent that it's then going to create a child from, or do you specify all different parameters for it? So depending on the number of parameters and the type of parameters, you may get one version of a function or another. So for example, here, even though it has the same name, printIt, we get there's one version here is a same printIt, but it takes two variables, an I and a j, right? So in this case, they wind up printing out the two of them, right? So it's the same name, different forms, right? Now, in the case of runtime polymorphism, where things are being sort of pushed onto, behaviors are being pushed onto an object on the fly, this is an example of that. This is more closer to what we're actually kind of showing in my example there before. So imagine you have a class called mammal, and mammals have a name, and this is what happens when you pet a mammal. When you pet the mammal, it just prints out you pet the mammal. Okay, so this is the base class. And then we have the dog version, which inherits from that. We have the cat version, which inherits from that. And all they do is they either overwrite the name and they override this method, right? And they don't do much of anything, but they do that. Now, so imagine then you have these mammals, just like I had a weapon, whether it be a weapon 2 or weapon 3 or just a base weapon. I could refer to them all in a similar way. So for example, here now, I might have a person which has a number of different pets that it has, and they're all mammals. All their pets are mammals. So I create a list of pets, which is basically a list of mammals. And then to that list, I assign a cat, another cat, a dog, right? I can add these things to this list of mammals because they inherited from the mammal base class. Right. Similarly, I could do those things that I was doing with the weapon system in the last video because they inherited from that common base class. I could refer to a weapon 2 via a weapon, or weapon 3 via a weapon, because they both derive from that class. Now, I could also refer to a weapon 3 via a weapon 2 because it derives from there. But anyway, you know, it's turtles all the way down, as they say. So now in this case, I could then in pets, right? I can just refer to that functionality, that pet, because each one of them has that pet. So there's the common way of referring to them, right? Very classy. Now, downcasting and upcasting. So you can change an object between its base and derived class. This is something I suppose I could have taken advantage of in the previous example as well, and upcast and downcast certain objects. Well, actually, I did do this. Yeah, I did do this. We'll see if we can figure out how, sort of. But okay, so the idea is to change an object between its base and derived class, or at least to refer to its functionality according to its base or derived class. So upcasting. And these sound, sometimes these feel a little bit backwards in name, but we'll just go with them. Upcasting, setting a derived class to be treated like its base class. Right? So for example, I could say, I can create a new way of referring to one class by its base, right? So I have an enemy, which is the base class. I declare a new reference to an enemy here, enemy, right? The enemy lowercase is the reference to this thing of the enemy class. And I upcast it to say, okay, boss is a derived class, but I upcast it to be just an enemy. It is no longer a boss with a capital B. Well, it is, but this reference to it just references that boss as if it were a base enemy. Okay, so that's what's going on there. That's the upcasting. Now, downcasting, you have to be careful in the case of downcasting, because you are potentially converting a base class back to its derived class. Now, this is careful. It can only be done if it would still be a legal object. It would be this illegal thing. You can't take something and then cast it to be something it never was. All right, so you want to be very careful, because these are just references that you're going to be going through here, right? So you could say, boss equals enemy as boss if, in this case, it was a boss to begin with, right? So you could say if enemy is boss, so you could say if weapon is weapon 3, then you could say weapon 3 equals weapon as weapon 3. Kind of get that same reference again. So it's ways to go back and forth of accessing or describing a reference in terms of some common or derived class. Right? There are some additional functions, additional functionality of classes that we can use, something called an abstract class. We're talking about abstract classes and also interface. Is complete. It has everything it does. It has everything it needs to be complete. You can call the class. Sometimes you might mark a class or function as incomplete using abstract, right? Which means that, yes, there is something. Function is a function marked as abstract, and it contains only an empty body and must have its behavior overridden in a derived class. So it's basically an abstract function is a placeholder within a base class for something that must be overridden in a derived class, right? So you're basically leaving a hole into which you must fill something, right? So you can't really use the abstract class on its own. The abstract keyword is thus similar to the virtual keyword in functionality, at least. It indicates a function to use the override keyword on. However, it must be overridden by the derived class. It is not optional. Normally, if you have a virtual function, it has its own functionality, and it can be overridden. But in the case of an abstract function, it has no functionality of its own, and it must be overridden by the derived class. Right? Now, an abstract class is one that contains at least one abstract function. Right? You can never create it on its own. It can only be used for inheritance. Okay, so it's a special case. You don't really need to be using them in all cases, but anyway, to just go backwards? No, I went forwards. Okay, here we go. So the normal class, we would have our normal mammal class and so on. This is the same example we saw before. But let's do this in terms of an abstract class as opposed to a regular class. So in this case, we might say, all right, we create a mammal class that we know has a pet functionality to it, a pet method in it, but we don't provide a default one. So it's saying, okay, you can't use this class on its own. You can't call this pet method here, but you can use it to derive these new classes from, as long as they are overriding this abstract method. And everything else works just the normal way, just like it would. It doesn't seem any different from this part here, but it's just saying, okay, you can't have just a mammal, right? So the other thing we're going to add now, we're going to talk about interfaces. Interfaces seem like a class that you might derive from, but it's not actually a class. It is an interface. An interface is a contract between itself and any class that implements it. This contract states that any class that implements the behavior, that interface must implement the interface's properties, methods, and/or events. Interface contains no implementation at all. It's really just sort of, I don't use the word, well, I want to use the word template, but template has some other meanings, but it's basically the, it's a signature. These have signatures of the functionality that the interface provides. To do anything on its own. It's not like a base abstract class. It just defines what a class should be implemented to do. An interface can inherit, and you can also inherit multiple interfaces. This is the one case that's different, right? So interfaces are basically collections of required but undefined functions. They are defined and they kind of look like classes, but they use keyword interface instead of class, right? They are meant for inheritance. Classes can only be derived from classes can be derived from any number of interfaces. And normally the convention is, we like to do this, we put I in front of them. So an I enumerator, for example, this is a interface, right? It doesn't contain any fields. It is only functions. Interfaces are meant to be public, right? And they must be implemented. Here's an example. Imagine you had a public interface iPet and a public interface iMove. You'd say, okay, you must provide an interface called pet. You must provide an interface called move. So a chinchilla here will be a pet, and it will be have the interface pet and move, so that you have to have these two functions in there. You have to provide them, right? Here's the move function and the pet function. Okay. And then you can refer to that interface. This is the cool part, right? This is the part where it says, all right, now that I have implemented this particular interface in this object, it doesn't matter what this object really is. It doesn't matter if it's a chinchilla or a mouse or a bunny or whatever. You just care that it provides that interface, which is that guarantee that it has that function within it, that method within it. Maybe 2 slides for it, so I won't make it its own presentation. So composition is similar to the idea of inheritance, and often you can use it in the place of inheritance, right? So for example, as you're adding functionality to, you think of prefabs in Unity. So prefabs increase their functionality. They are basically game objects that have additional functionality built into them, not because of inheritance, but by the fact that they have multiple components within them, right? So composition is similar to the idea of inheritance, except it's based on what is called a has a relationship as opposed to a is a relationship, right? So does this object have a certain sort of component within it, right? As opposed to, is it a type of component? So inheritance creates a hierarchy whereby a cat or a dog or something is a mammal. But composition indicates that something has a property. An enemy has a weapon, right? So a enemy object, the hero has a weapon. The enemy has a weapon. Any component or any object in the game might have that component, but they might not be derived from a similar class, right? So that's the other sort of object-oriented technique that we use. Often this is more powerful than inheritance because any number of classes can be used in a composition. So in other words, a game object can have any number of components on it, for example, and it does not create a complex hierarchy this way, right? So we can, have this sort of flat where one game object has lots of components without having them derive one from another, and on. Right? So it's a simple way to do that, sort of create this sort of inheritance-like behavior by using prefabs and using multiple components per object and so on, right? So for example, this should feel kind of familiar, where we have some sort of movement type, some kind of structure in here. It might be a game object, or it might be a UI element or something like that, where that is part of the definition of that class, right? We see that a lot. We've used that a lot already. And then we can refer to that within there because it has that movement type. Then we can work with it. It's not as clean from an interface perspective, but from a construction and architecture perspective, it has certain advantages. All right. So I'm going to stop there. So we introduced a whole lot of stuff. And none of this is really required for the particular project. So we'll kind of leave it there as general information. And hopefully this comes in handy as you're working on things. And I will be looking for this stuff in the final project so that you will be using inheritance and so on in the final project. Okay, that's it for now. If you have any questions regarding your projects, do reach out to me via Discord or Discord channel server, and otherwise, post comments on these videos and things, and that'll all pop up in my feed as well. Looking forward to seeing the results. All right, take care.